Let's solve the following linear inequality. We'll begin by transposing 4 from the right hand side to the left hand side, such that we have 7x minus 5 divided by 8x plus 3, so minus 5 greater than 0. Combining the two terms on the left hand side, we get negative 25x minus 17 divided by 8x plus 3. So this is going to be greater than 0. Now what we'll do, we'll multiply both sides with negative 1, but before doing that, let me state a property. That means if we have two numbers a and b, and let's say a is greater than b, and we also have another number c which is negative, that means less than 0, then it follows that if we multiply a with c and b with c, that means the sign of the inequality will flip, then we'll get ac less than bc. So similarly, here we are going to multiply both sides with negative 1, we will get 25x plus 17. This is divided by 8x plus 3, and the value will now be less than 0. Right. So this is the linear inequality whose solution we'll try to find, and the solution will be same as that of the original inequality. This gives us immediately two cases. The case number 1 being, we'll consider the numerator, which is 25x plus 17. We'll consider that this is a positive number, and we'll consider the denominator 8x plus 3 to be a negative number, which simply means that we're dividing a positive number by a negative number. That gives us a negative value, and the inequality will be true because it will be less than 0. Now let's solve this inequality. So we have 25x greater than negative 17 and 8x is less than negative 3. Now we'll divide both sides of the first inequality with 25, which is a positive number, so the sign of the inequality is not going to get affected. We'll have x greater than negative 17 over 25. And similarly, for the second inequality, we'll divide both sides with 8, which 8 being a positive number, the sign of the inequality is not going to change. So we'll have x less than negative 3 over 8. Now let's try to find out the common solution to both of the two linear inequality. For this, we are going to consider a number 9. So where both of them are negative, so we'll have to take this number to the left of 0, and we have negative 3 over 8 and negative 17 over 25. So here negative 17 over 25 is smaller compared to negative 3 over 8. Now let's consider the first inequality we stated. We have to consider all the values of x which is greater than negative 17 over 25. So we'll have to consider all the values of x lying to the right hand side of negative 17 over 25, and x less than negative 3 over 8 means, or consider all the values of x which is less than negative 3 over 8. So that means the values of x will be lying to the left of negative 3 over 8. So from here we can see that there is a common solution which satisfies both of the two inequations simultaneously. So this is the common region, and this can be expressed as the values of x which lies between negative 17 over 25. That means x is greater than negative 17 over 25 and less than negative 3 over 8. Right. So this is the result that we have obtained when we consider case number 1. Now we'll consider a second case, case number 2. The case number 2, what we'll do, we'll consider 25x plus 17 to be a negative number, that means less than 0. And we will consider the denominator, which is 8x plus 3, to be a positive number. Now we have a negative number divided by a positive number, which is still negative, and the inequality holds true. So solving this gives us x as less than negative 17 over 25 and 8x plus 3 greater than 0. When we solve it, we get x greater than negative 3 over 8. Now we will consider the number line. On the number line, we have negative 17 over 25, negative 3 over 8, and 0. The first inequality states that we have to consider all the values of x which is less than negative 17 over 25. That means all the values of x lying to the left of negative 17 over 25. And x greater than negative 3 over 8 means all the values of x which is lying to the right of negative 3 over 8. Clearly, we do not see any intersection between the two lines. That means there is no common solution here. None of the value of x is going to satisfy both of the two inequalities simultaneously. So here we do not have any solution. So there is no solution here, which means that we only have one solution obtained from case number 1, and that is going to be our final solution to the given linear inequality. Now we can also express this given linear inequality in an interval form. That this is the same as negative 70 into 25 going to negative 3 over 8, and this will be an open interval, that because the endpoints, which is negative 17 over 25 and negative 3 over 8, these are not part of the solution.